Okay, this is the second video we're doing on graphing. Last time we focused on transformations outside of your function, multiplying on the outside to change your amplitude, adding and subtracting on the outside to shift vertically. Now we're going to do transformations on the inside of your function, transformations affecting the x on the inside. So again, we'll harken back to 171 that you've done before. Before, when you had x squared, well, regular parabola. If you then replace x squared with x plus 2 squared, if you remember, adding and subtracting on the inside shifts your graph horizontally. Adding and subtracting on the outside shifts it vertically. Adding and subtracting on the inside shifts it horizontally. And if we do plus 2, normally addition goes right, but because it's on the inside of the parentheses, it reverses, so it'll go left. And we'll look just like that. The exact same parabola shifted to the left. If it worked that way in 171, it'll work that way in 172 without trig graphs. So, let's see. This time, I think in the last video we used sine waves, so this time we'll use cosine waves. F of x equals cosine x. You know what the basic graph looks like. I'm not going to graph it because it might look bizarre with both of them on top of each other. But the regular cosine wave starts up top, goes down to its minimum, and then back up to its maximum. But we don't want cosine x, we want cosine x plus pi. Well, if I'm adding on the inside, that's a horizontal translation. And let's see, since it's x plus pi, it should be the left by pi. So now just graph that. In the last video I said, easiest way to do this, and for my benefit so I can grade your work, list the 5 key points, the 5 key x values for your graph. So first we do the starting point. Normally the starting point is 0, but since I'm shifting pi to the left, my starting point is now 0 minus pi, which is minus pi. My period for the cosine wave is still 2 pi, so what's my ending value? If I start at negative pi, if my period is 2 pi, I can just add that. 2 pi and adding negative pi is just subtraction. And pi should be my ending value. Now, in order to find the other 3 values, we cut this interval in half. Halfway between negative pi and pi is obviously 0. Now break each of these intervals in half. Halfway between negative pi and 0 is negative pi over 2. Halfway between 0 and pi is positive pi over 2. Now, do your y values. Let's see, it's a regular cosine wave. Cosine wave starts at its maximum, so we'll say that's 1. Then it goes through equilibrium, which is 0. Then it goes through its minimum, which we'll say is negative 1. Then it goes through equilibrium. Then it goes back to its maximum. Now just connect the dots. So I go down, back up, and there's my cosine wave. A regular cosine wave shifted pi to the left. Good. We are ultimately going to combine all of these transformations together into some really nice graphs. But for right now, if we can do a horizontal translation, last time we also did a vertical stretch and compression, so we might as well work on a horizontal stretch or compression. Again, if we harken back to our regular 171, if I have f of x equals x squared, I can do f of x equals 2x squared. How would the regular graph look? Well, let's see. The regular parabola would look like this. If I do this one, well, at 0, I'm still going to get 0. At 1, I'll get 2 times 1, 2 squared, which is 4. At 2, I'll get 2 times 2, which is 4 squared, 16. And we see it just gets really steep really fast. It looks a lot like a vertical stretch, but in actuality, since the number we're multiplying is inside the parentheses, it actually affects the graph horizontally, and we say it's a horizontal compression. vertical stretches look like horizontal compressions, and vertical compressions look like horizontal stretches. Irregardless, if the terminology is a little bit confusing, as long as you can look at that and understand how to graph it correctly, we'll be completely fine. Now, we want to take this and transition over to our trig. So, suppose we have f of x equals sine of 2x. Well, let's see. I can graph, for this one, I'll graph my normal sine wave. And we'll label our key x values. That's 0. This is pi over 2. This is pi right here. That's 3 pi over 2. And then that's 2 pi where we finished. Well, now, if I multiply by 2 on the inside, that's a horizontal stretch or compression. Much like with the x squared, since that's bigger than 1, it'll be a horizontal compression, which looks like a vertical stretch. But essentially what that means is, I take this wave right here, and I kind of compress it like that. And how will that affect my graph? Well, if I take this wave and compress it right here, essentially I take this whole graph and make it shorter. The length of the graph this way, in terms of x, is actually the period. Which means if I compress it, I change the period. We said last time, when you multiply something on the outside, that affects the amplitude. If you multiply by something on the inside, you affect the period. As far as figuring out what my new period is going to be, there's a simple trick. You take your old period, 2 pi. If this was a tangent wave, we'd have to use pi, because the period of tangent is pi. But for this, the regular period is 2 pi. Whatever is multiplied on the outside, divide it. Now, if I simplify that, I get pi. So that's my new period. If you think about it, it makes sense. If I multiply by 2 on the inside, I'm essentially speeding it up twice as much. It's going twice as fast. So logically, if it's going twice as fast, it should take half as long. It did take 2 pi before, now it's going to take 1 pi. So it makes sense. But now, essentially, I just draw my regular sine wave, but I do it with a period of pi as opposed to 2 pi. So now I have to find those key points, and they'll be slightly different. Let's see, I can have my starting value, 0. My ending value now will be pi, because that's where the period ends. Now I need to find the 3 other key points I need. Well, first we find the midpoint. Halfway between 0 and pi is pi over 2. We already have that one, so we're good. Now find the midpoints here and here. What's halfway between 0 and pi over 2? Pi over 4. What's halfway between pi over 2 and pi? 3 pi over 4. 0, 1/4, 1/2, 3/4, 1. Makes sense. Now just draw a sine wave. Let's see. The sine starts at 0, then it goes to its maximum, which is 1, then it goes to equilibrium again, 0, then it goes to its minimum, -1, then it goes back to equilibrium. That's a little low, I think. Maybe right there. Now just connect the dots. Up to max, down to equilibrium, down to min here. And there we go. It's a regular sine wave, it's just compressed or sped up. So it gets through its entire period faster. This is maybe the most confusing part when you have to change your periods and change your x's and shift them around. So I want to do one more of these on this video, just kind of tying it all together. So let's see, suppose I have f of x equals sine of 2x plus pi. Now we essentially have both transformations we've been working on in this video. We're multiplying by something and we're adding or subtracting something. There is one trick to this though. Before you actually find any transformations, you have to factor what's on the inside of the parentheses. Essentially, our transformations only work if x is by itself. So we have to factor this, and you factor out the 2, which leaves me with x plus pi over 2. This looks a little bit bizarre. I factor the 2 out of the pi, which leaves me with pi over 2. You've done something similar when we do completing the square, where we factor to make the leading coefficient 1. This is the same principle here. This has to be 1, so you factor the 2 out, and if it's not a common factor over here, you just divide by it. If you're a little concerned by that, just distribute, make sure what you did is correct. If I distribute 2 times x is 2x, 2 times pi over 2, the 2's cancel, and it's pi. So that's the same thing. Now, what transformations do I have? Well, the 2, when I multiply by 2, that affects my period. And let's see, the rule is whatever the original period is, 2 pi, I divide by what's out in front, 2. My new period is pi. Then, if I add on the inside, that shifts me horizontally. Let's see, that should go, if I add, I go to the left. I go to the left pi over 2. Now I have my transformations. So let's see, what do? Sketch my key points. I need a starting value. Sign starts at 0, but I went to the left pi over 2. So I'll go to negative pi over 2. And one thing I'll point out is you guys actually do these graphs for me and turn them in. Just because you're compressing your graph doesn't mean you have to compress the points and make them really small so I can barely see what you're writing. You can space them out a little so I can read them. That doesn't really matter. The scale doesn't matter. But let's see. Now I ended negative pi over 2. My period is pi. So where do I end here? Negative pi over 2 plus pi is positive pi over 2. Now I need a middle value. Halfway between negative pi over 2 and positive pi over 2 is obviously 0. Now find the middle values there. Halfway between negative pi over 2, negative a half, and 0 is negative pi over 4. Halfway between 0 and pi over 2 is positive pi over 4. Now, draw my y values. Let's see. We did our transformation, so the sine wave starts at 0. Then it goes up to its max. We'll say that's 1. Then it goes to equilibrium again. Then it goes to its min negative 1. Then it goes back to equilibrium. If I connect my dots, there we go. There's my sine wave. This is maybe the trickiest part algebraically, being able to correctly figure out what your different transformations are inside the parentheses, making sure you factor correctly, and then making sure you find the correct starting point, ending point, and all the points in between. I'm going to do another video where I combine all the transformations we've done so far and just sketch a couple of graphs using all the transformations at once so we can see them all worked out together.